Welcome to Pod 4 Journal Club. Today, we're going to break down a really fascinating paper that honestly reveals some pretty deep vulnerabilities in the AI models we all interact with every single day.
All right, so let's dive right in. We put a lot of trust in AI developers to build these robust safety features into large language models. But this paper asks a really critical question. What if those safety nets, what if they aren't just flawed? What if they're fundamentally mismatched to the very nature of the AI they're supposed to be protecting?
First up, let's talk about what this paper calls the AI safety paradox. It's a real puzzle. We pour enormous resources into training these models to be helpful and harmless, right? And yet, attackers, they just constantly seem to find new ways to make them do bad things.
And this creates this relentless cat-and-mouse game. You've got developers patching one vulnerability, and then the jailbreakers, they get creative and find another one. It really makes you wonder, is this a game that the defenders can ever truly win?
And here we get to the core idea of the paper. The authors suggest that safety training doesn't actually delete the model's dangerous knowledge. Nope, it just teaches the model not to use it. You can think of it like sweeping dirt under a rug. The dirt is still there, it's just hidden. And a clever attacker, they might know exactly how to lift that rug.
Okay, so to really get how these jailbreaks work, we first have to understand how the safety training itself is built, and maybe more importantly, where the cracks in that foundation are.
The main tool for this is a technique called reinforcement learning from human feedback, or RLHF. This is kind of the secret sauce behind models like ChatGPT. To put it simply, humans give the AI a thumbs up or thumbs down on its responses, and the AI just learns to generate more of those thumbs up answers. That's basically how we align it with our values.
Now the thing is, researchers have found this training can fail in two main ways. The first one is called competing objectives. That's where you trick the AI by making a harmful request sound really helpful. But this paper, it focuses on the second and much more subtle failure mode, mismatched generalization.
And this is such a great analogy. Just imagine, the model's general knowledge and reasoning, everything it learned from the internet, is like a massive, sprawling city. But its safety training? That's like stationing guards in just a few specific neighborhoods. So the attack we're about to look at doesn't even try to confront the guards head-on. No, it takes place in the vast, unguarded parts of that city.
So, how did these researchers actually exploit that unguarded territory? Well, they didn't use one single, powerful attack. Instead, they did something really clever. They combined several weaker techniques into something way more potent.
They call it a compound jailbreak, and it has three parts. First, they frame the harmful request as an educational thing, asking the model to compare good and bad examples. Second, they gave it this persona of a security expert, which makes the whole task feel like a legitimate job. And third, and this is key, they made it rate its own confidence, which adds this whole extra layer of mental work.
And this quote from the paper just perfectly captures the genius of this approach. It's not about directly fighting the safety rules at all. It's about creating a kind of cognitive overload that, it makes the model simply forget to apply them. I love this explanation. So imagine the model is already juggling one ball for follow my instructions and another one for follow the safety rules. What this attack does is it's like throwing three more balls into the mix. Compare these things, act like an expert, rate your confidence. And in all that chaos of trying to catch everything, the model drops the one ball it can afford to ignore in that moment, the safety ball.
Okay, so that's the theory and the method. It's a super clever idea, right? But the big question is, did it actually work? Well, the results were pretty shocking, to be honest. Their attack success rate, or ASR, for this compound jailbreak hit a staggering 71.4%. Let that sink in. That means nearly 3 out of every 4 times they tried this, the model produced the harmful content it was explicitly trained to refuse. Wow. But here's what's really wild. Look at this direct comparison. When they used just one of the attack techniques on its own, it only worked about 14% of the time. Not great. But when they combined them, it created this incredible synergistic effect that quintupled the success rate. We're not talking about just addition here. This is multiplication. And if we look closer at the data, we can see exactly how this whole thing builds up. This table shows the breakdown, and the crucial finding is right there, highlighted for you. The biggest jump in effectiveness came from adding that self-assessment demand, that extra little bit of mental work, that third juggling ball we talked about. That was the absolute key to overwhelming the model's defenses.
But the vulnerabilities from this cognitive overload, they didn't even stop there. The researchers found something that was frankly even more concerning when the AI acts as an agent, when it's performing multi-step tasks. They called this phenomenon contextual inertia.
And this just brilliantly illustrates the danger. So you start the AI on a perfectly safe task, but once it's locked in and focused, you inject a harmful instruction right in the middle of its workflow. And the model is so committed to that original context that it just complies. It completely ignores the new danger. The vulnerability rate in these tests, a near-perfect 98.8%.
So this brings us to the crucial point. If these pretty simple compound attacks are so devastatingly effective, what on earth does this mean for the future of AI safety? I mean, how are we supposed to defend these systems? The paper's conclusion is, well, it's pretty sobering. Just trying to patch the model with more and more training, more RLHF, it's just not a sustainable solution. Why? Because the number of ways you can combine simple instructions is practically infinite. So instead, the authors argue we need new structural defenses. Things like a separate system that could flag prompts that seem suspiciously complex before they even get to the AI.
Ultimately, what this experiment does is provide really powerful evidence for that mismatched generalization idea we talked about earlier. The safety training is specific, it's brittle, it's narrow. But the AI's core capabilities? They're general, flexible, and just vast. You can't possibly teach it about every creative combination of attacks out there because its own ability to combine ideas will always be one step ahead.
And that leaves us with this final, really critical question. This research forces us to think beyond just trying to train good AIs. If we can't bake all the rules into the model itself, then we have to start thinking about the entire system around it, the inputs, the outputs, the whole context. It's a fundamental shift in how we approach AI safety, and honestly, it's a question we urgently need to find an answer to.